This is part 2 of our C# introductory series, storing information. In a computer program, we need to be able to store data. One of the powers of computer software is the fact that it can react to changes in its environment. And the environment is generally characterized by storing that information in what we refer to as variables. Variables in computer science are named storage locations. In a strongly typed language or in a statically typed language, they store a particular type of information. So when a variable is created, it has a type associated with it. And C# is a case-sensitive language, which means that when you name a variable, the spelling, the capitalization, is significant. For example, here I show that last name, it's not the same as last name if the L and N are capitalized or lowercase. Got to keep that in mind when you're building your C# programs. And generally, you don't want to utilize case as a distinguishing feature between variables. Stick with a scheme that you come up with to name your variables, and your code will then be more understandable and more readable. Along those same lines, you should use meaningful variable names. Here's two little code snippets of C# code, both of which are perfectly acceptable, will function correctly, and will output you are named and whatever, John Doe, for example. But here in the first example, I have named the variables x and y. And in the second example, I've named the variables first name and last name. The variable names contain context as to what the data they'll be storing is. And so therefore it helps for you to understand your own code, and it also helps if you're having other people look at your code. So instead of naming everything x and y just because that's what you always learned as a kid in algebra class, what variables are named, you got to get over that and get into the habit of naming things in a meaningful way. When we create a variable in C#, we generally create them with types associated with them, meaning that a specific variable will only be able to store a specific type of information. In the right-hand side here, you see a table showing you a variety of the types available in the C# language. Generally, they're in groupings here, and one of the groupings are the integer types. These include the int, the uint, the long, the ulong, the short, and the ushort. These are all types of integer storage, and the main distinguishing characteristic between them is how many bits are being used to store the numbers. So for example, the type int, is a 32-bit signed integer, which means that it can store both positive and negative values. And with 32 bits, that leaves us, we always use 1 bit to store the sign, whether it's positive or negative, and so that leaves us 31 bits, or a little over 2 billion numbers that can be stored positive and negatively. In a 16-bit integer, short, for example, we would get from minus 32,768 to positive 32,767. This is a number that comes up all over the place in introductory computer science. And if you go to the long, longs are 64-bit, I believe, and as a result, you get to astronomically large numbers that can be stored with 64 bits. And if you want to use only positive numbers, then that extra bit, that 32nd bit, for example, in a uint, gets to be used for numbers. So you get up to 60. Well, you get up to twice as large as the signed variables. The other built-in types are doubles. These are commonly used to store real numbers, so things with a floating point like 57.64, or in a scientific notation, something with a power of 10 multiplier. Doubles are extremely high precision. They use a lot of bits, and there are less precise versions called a float or a single that can also store floating point numbers. Strings store text, booleans store true and false, and characters store a single character, like aka a letter, like an A or a B. These are generally the most commonly used ones. You can see in the table there's a few that we didn't talk about, but if you're doing most of your programming, you're going to use ints, strings, doubles, bools, and possibly characters. So let's go over to Visual Studio here and take a look at how we might declare or create some of these variables. When we create a variable, when we name it, this is called declaring it. And so it starts with the type. So if I wanted an integer variable, I would start with, for example, int, and now I can give it a name. So how about I say age? And I can, at this point, be done. And I now have a variable named age, and I can do whatever I want with it. So what do I want to do with it? I want to assign it a value. So in programming, in C language, this equal sign that you see appearing here is actually an assignment operator. It is not saying that age is equal to something in a mathematical sense. It is going to take whatever appears on the right-hand side of this expression and evaluate it and take the value and stick it into age. So if I do something simple like age equals 12, the variable age now has the value 12. Is that memory location that has been named age in our program is now storing the value 12. And 12 is an integer, so because this is of type int, this is an acceptable acceptable statement. You'll notice that in C#, all of these lines of code are ending with a semicolon. That is the proper syntax to end a statement in C#. I can do other things too, where I might be able to say a statement, for example, age is equal to, and I could do math here. I could do something like 5 times 37. And again, it will evaluate the right-hand side. So it would actually do the multiplication of 5 times 37 and store the result in the age field. We can also do things in C# that don't mean the same things as they would in a math situation. For example, this age equals 5 times 37 is mathematically valid. If I say age is equal to 5 times age, now in a mathematical sense, the only value of age that meets this condition would be 0. But here, this is not an equality. This is an assignment. So evaluate the right-hand side and assign it to the value of age. So this takes the current value of age, which is whatever 5 times 37 is. I'm going to go back and I'm going to get rid of this line. So I'm going to get rid of this line now that we're talking about it. So if I was to say that age is 12, then 5 times 12 is 60. So I would get age now equal to 60. So it takes the current value of age, multiplies it out, and then assigns it to the variable age. Now the one thing I can't do with age is I could not do something like 12.5. You'll notice that in the development environment here, it puts a little red line, squiggly line under there, very much like you'd see in a text editor that shows you that you've done something wrong. And here it says it cannot implicitly convert type float to int. In other words, I can't store 12.5 into the variable age, because age, again, is an integer. So that's not acceptable. So if I wanted to store that, I'd need a different type. I could do something like double. How about cost? And I can assign that something right here on this line if I wanted to, 12.5. This is a case where I have both defined or declared the variable cost, and I have assigned it a value, an initial value. The exact same thing as doing these two lines of code. It's just shorthand. So now I can do things like cost is equal to cost divided by 3, for example. And that value would end up being a fractional value, and that's acceptable because the cost is a double. A couple of the other types that we talked about were string, so I could make a variable to be of type string, and this I can say is message, and I could do something like message is equal to hello world. That'd be an example. Whoops, put my semicolon in the wrong spot. That's perfectly acceptable. I can also do something like message is equal to 38, because here that 3 and the 8 are just characters. They're forming a string. It's not mathematically the number 38. It is the symbol, the sequence of symbols 3, 8, which means I couldn't do math with it. For example, I couldn't do something like cost is equal to message divided by age. It's going to complain and say that, sorry, can't do that to a string and an integer. There are some stuff we can do later to convert this string into a number, and we'll learn that later. But you can see how typing tells us when we do things wrong. It's able to get a little context from the types to tell us whether stuff is working well or not. The other type that we might be running into is something called bool. And a bool actually stores a true and a false value. So I might be something like done is equal to false. I could later set done equal to true. This is something we'll be using in our looping later on. So let's hop back over here to our PowerPoint and see what's next. Console, yes, console applications. Generally, we're going to build console applications for our examples here. This allows us to focus primarily on the C language and not get buried in details of creating windows and responding to user events and things like that. We'll do that later, and it will show the power of the .NET framework and some of this development environment that Microsoft provides. But in the short term, we're just going to stick with some console applications so we can focus on the language. So in order to do that, we have to be able to get information into the system and out of the system. So the console.writeLine and console.write commands will allow us to put information on the screen, and the console.readLine and the console.read will allow us to get information from the user. And when we do this, we're going to use the brand new C# version 6 way of formatting strings. So this command, console.writeLine, and whatever happens inside of the parentheses is being passed to the console.writeLine function. We'll learn about functions later, but in this context, just remember that whatever you put in the parentheses is what gets sent to the console. And the difference between the WriteLine and write version. WriteLine will write out your text and go to the next line. Console.write will write out your text and then just be sitting and waiting at the end of that text for more stuff to be printed out. Console.readLine, it will read in whatever you type up to when you hit enter. And we don't really use console.read very much. So this statement, console.writeLine, and that $sign that you see there is actually part of this new C# version 6. It's called an interpolated string. And so I've color coded it a little bit. The stuff inside the quotes is a string. We always create a string of information in C# by putting double quotes around it. And the stuff that I have in green is what we call string literal. Those words and those characters will actually be copied directly out to the output. Now, the stuff that's inside curly braces, it will not appear. The curly braces will not appear in the output. That's assigned to the WriteLine command that you need to do some replacement. You need to go find the variable called name and put the value of it in here. So, for example, if we had the variables name equals David and count equals 7,800, when we actually execute the WriteLine, it's going to replace the curly braces name with the word David and replace the count 7,800 with, or count variable with the value 7,800, and you would see an output that looks like this on the screen. Hello, David, you have 7,800 miles. This is a really great and easy way to produce formatted results based off of values stored in variables. So let's go over again to C# and see if we can get a few examples of this console. First thing we're going to need to do is, in order to use the console programs, I have to use this command using system.io. These using statements are what allows us to bring in additional functionality into our program. Think of them as libraries or groupings of useful functions. We'll go into detail about how using statements work a little bit later. But for now, if you want to use the console.readline or writeline, you need this system.io to be in your program. So let's come back here and let's go ahead and see what some of these things are as we print them out. So I'm going to get rid of a little bit of this stuff, and we'll just stick with this age equals 12, age equals age times 5. So I could throw in a line here and say console.writeline. And what do I want to write out? I want to write out the word age is, and then I want to put in the value. So I'm going to put in one of those curly braces, and I want to put in the name of the variable I want to put here, age. This is brand new in C# interpolated strings, and the old way was, you'll see placeholders here like 1 and 0, and then I would have to tack on the variables afterwards. This way makes a lot more sense, and I really like the change they made. And I have to tell it this is an interpolated string, so I have to put that $sign in front of it. I don't always have to do that. For example, I could write out console.writeline hi there, and I don't, because it's not an interpolated string, because there's nothing being placed inside these curly braces, I don't have to put that $sign out in front of it. So and then I could do this again, and put in the word ages now, and so what it'll do is it'll take the value age, it should print it out in this spot right here, then it should calculate it 5 times that value and print it out. And one thing we learn when we do console applications is we always want to end with a console.readline. And the reason is this program will run, execute, do all this stuff, print it out on the screen, and then close the console when it's done, unless I have this last line here, which is just here to make it pause. So generally, when you're doing console programming, just always toss that line in the end, and you'll get a nice little pause. So here we'll go. We'll go ahead and run it. The computer compiles it, executes it, and here's my function, or my console. So it says hi there, age is 12, age is now 60. It printed out exactly what we expected. You can print out integers, you can print out other things. So for example, we might do something like double cost is equal to, let's do something like 45 divided by age, and now I can do something like console the write line function is pretty smart and can do a lot of things, and there's ways to format this if you really want, and we'll go into there later. Ooh, cost is 0. It did an integer division for me. Let's see, 45.0. See if we get better that way. There we go. 0.75. I think I just demonstrated something about C# that I wasn't intending, but it's a good demonstration anyway. If you this division operator can do division in different ways. You can divide floating point by floating point or floating point by integer by division, and this does mathematical division like you're used to. If I tell it to divide an integer by another integer, it actually does integer division, which means that it's going to give you back the closest integer to your answer. So it cuts them off, it drops them. So you have to get used to that and be careful of that when you're doing things. So that was a little extra bonus demo there. Okay, so let's hop back over here. The other thing we'll talk about briefly is arrays. We've talked about how to declare variables where you create one of them at a time. But if I wanted to store, for example, 50 people's names, I wouldn't want to create a variable called person1, person2, person3, because I need to be able to have the computer like walk through each one or add on and things like that. So that's where arrays come in. Arrays are groups of similar information that are individually addressable by what we call an index. So if I tell it to go to person number 12, it'll go down to the 12th person. It's not really the 12th person. It's actually the 13th person, but we'll show that in a second. But think of the index as a way of asking for a specific one out of a list of items. I have to be careful when I use the word list because in computer science it means something different than an array, but colloquially you get the idea. So if I want to declare an integer, or an array called myArray here, I would use a format similar to this. You'll see the base type int is here, and you'll see that there are square brackets next to it. Those square brackets tell it that it's now going to be an array of integers. We're going to call it myArray, and then I use this weird syntax that we'll explain here in a few minutes, where I say equals new, and then again the type, and this 8 here is telling me how many items in my list or my array am I going to create. So you can think of that as sort of a table. A table that has indexes 0 through 7 and a spot to store each of those integers. So how many items are there? There's 8, because that's what I did when I declared it, and it starts with 0. We call this 0 indexed. So the very first item in the array is not item number 1, it's actually item number 0. It's something that has been true of the C family of languages from the beginning. Items are 0 indexed in C languages, so just get used to it. So if I want to assign something to one of these storage locations, I would use a line similar to this. myArray and then 4. Here, the 4 inside of those brackets is the index. In other words, go to index number 4. Not the 4th item, but index number 4. So that would be here in our grid view of this. And so I am now doing an assignment. That's what the equal statement says. And it wants to take on the value 15. So 15 would be stored in that particular location. The thing about arrays is they are not restricted to only one dimension. You don't just have to have a long list of things. You could have a grid of things. So if I wanted to declare a two-dimensional array called myArray, I would use a type. In this case, I'm going to make it an array of strings. And there's the square brackets again, telling it that it's going to be an array. And there's a comma in there, which means that I should have two elements, a width and a height, for example, or a height and a width. You can interpret it either way. The computer doesn't care. But in my brain, I usually think of it as height and width. And then there's that new keyword again, which we'll talk about in a second. And then the type over again, and then there's going to be 5 rows and 3 columns. Or you can think of it as 5 columns and 3 rows. So that would create a grid like this. Here we have 5 rows and 3 columns, both 0 indexed. So if I were to say, for example, myArray 1, 0 is equal to high, that means take the value high and place it in location 1, 0, it would go there. myArray 2, 2 is going to be assigned the value Bob, so 2, 2 would be that box over there. It would take on the value Bob. Arrays can have more than just 2 dimensions, so if you wanted to have it have as 3 dimensions or 4 or 5 or 6, you just put more commas in there. The the concept of thinking of it as a table like this begins to get bizarre because it's hard for people to visualize higher order dimensions, and you just got to get used to the fact that it's just those are parameters that will allow you to find the particular value you want. The thing about arrays is that the items in the array are all the same. So generally they're arrays of something. And we'll see later that you can make them arrays of very complicated objects that store multiple pieces of information within them. But for now, we're going to talk about arrays primarily as storing base types. So let's go back over and take a look at creating an array here. So let's get rid of all this junk, and I'll declare an array here. So we'll make it an array of integers, so int. And then I put in the square brackets, and now I have to give it a name. So this is my name of so I'll call it my array. And now I have to tell it how big it is. So this new keyword is actually telling the compiler to put aside some storage somewhere that's going to hold how big of this stuff is that I want to use. So I'm going to make it of integers, and how many do I want to store? Let's say I want to store 10. And so this will hold 10 integers. This number can be big too. I could store 10,000 integers if I really wanted to. And so, for example, I now have this thing called my array. And so if I want to assign something to one of those elements, I would say my array, and I use the square brackets again. And so, for example, the very first element in the array, I might set it equal to, I don't know, 12. And my array, and I might be able to make say the fifth one, and that might equal 42. You can individually address whatever area, item in the array you want. Now the cool thing in arrays, that doesn't have to be a fixed number. So for example, if I had defined an integer to be 13, so I have this value I now that's got a value of 13, I could say my array value I is equal to 112. So it's going to take the value of I, which is 13, and use that as an index into my array and store this value 112. And this will come in super handy when we begin to do loops, which will allow this value I to move from some starting value to some final value, and you can move your way all the way through this array. So for example, I could do console.writeLine, and the thing I'm going to write out would be, say, for example, my array number 13, and we should expect that to therefore to print out the value 112 if everything went right. So we'll do a console.readline to pause and run it, and we get 112 as expected. So what about this new operator? Said I would mention in a couple of minutes. Well, here it is. So when we store a statement like declare a variable like myString and say string equals, or string myString equals hello, there's no new keyword in there. What's the deal? But when I declare a variable array like this two-dimensional array called myArray, it does have that new string in there. And that has to do with the way that information is stored in a computer. Behind the scenes, there are actually two objects or two places that stuff is stored. It's called the stack and the heap. Thankfully, you don't really need to know too much about this anymore compared to the old days. A lot of this is handled for you. But the thing to remember is anything stored on the stack is local to your computer. It's held closely to the CPU, and it runs particularly fast, and management of that information is handled entirely by the software. And so in a way, when you declare what we refer to as local variables, or when we declare statically defined variables like this, they go on the stack. So that first line would actually create a storage location in this piece of memory called the stack. it would be named myString, and the word hello would actually go get stored there. It actually holds the values themselves. Later we'll talk about what a stack actually is and why it's such an efficient way of storing information in a program. But just for now, just remember that the stacks are generally efficient and quick. But there's not as much stack memory as for example, if you have 16 gigabytes of the memory in your computer, not all of that is available to the stack of your program while it's running. That big giant bag of memory that's out there and addressable is actually referred to as the heap. So big things like this array that might be 10,000 by 10,000 by 10,000, that's a lot of bytes. And so what we do is we do sort of a two-stage process. So the second statement, string myArray, would actually create an item on the stack called myArray. But that is not the entire storage location of this array of information, which could potentially be extremely large. This is actually just a small little storage item on the stack, which is a variable called myArray that actually is going to be a location of where the real information is in the heap. So when I do that, it creates this little memory location in the stack, and it also grabs a big memory location in the heap to hold all of that information. And it points the memory location in the stack to the location where my stuff is stored in the heap. In the old days, this was always referred to as a pointer. Nowadays, we generally refer to this as a reference variable. And those of you, or if you talk to any old-time programmers that dealt with C directly, you will find that you spent a lot of time managing how these pointers were created and destroyed, and you were responsible entirely with asking the computer to give you memory and giving it back when you were done. Thankfully, those days are over with managed code. This stuff happens sort of behind the scenes, and there's this fabulous thing called a garbage collection, which will take care of cleaning up the heap and the stack as your program runs, and it's a lot less work, but of course you have a lot less control. So there's always trade-offs, but there's a quick little version of why we use the new operator. For some things in the language, we have to allocate them on the heap, and the new keyword does that. It creates what we refer to as an instance of this object. So we'll come back to that in detail in a future video.